Hi there. For this lesson, we're going to be talking about using a skewer to measure objects that you're looking at from life and measuring them. So the skewer is used in a lot of different ways. We can use it to compare the width and the length of an object. We can use it to check how objects align vertically or align horizontally. We can use the skewer kind of like a level or like a plumb line that we'll show you in a minute here. But there's three key things to remember whenever you're using a measuring device to gauge the angle or a distance on an object that you're looking at. So we'll go through that first. The first thing is you want to make sure that you only have one angle of the object. So if both of your eyes are open, you're going to get a double image, either of your hand or a double image of the thing that you're trying to measure. So if you can close one eye, if you can wink, that really helps isolate just a single view. It's more consistent. You don't keep shifting from your right eye's view to your left eye's view. So the first thing to do is close one eye so that you just have a monocular flattened view of the object that you're trying to draw. The second thing that's really important is to always make sure that your measuring tool stays the same distance from your eye for each measurement. So you wouldn't want to take one measurement with the skewer straight out with your arm locked, but then take the second measurement, by bending your elbow and bringing it closer to your eye. So it's really important that the skewer stays the same distance from your eye as you're comparing two different measurements. Without locking that elbow, you can't ensure that your tool is always staying that consistent distance from your eye. The third thing to remember is that whatever you're using as a measuring tool, whether it's a skewer, later on we're going to be talking about using some sort of L tool that you build yourself to help you judge angles. It may be that you have some sort of ruler or measuring gauge that you're holding out there to compare measurements. Whatever tool you're using, even a protractor or other things, the key thing is that whatever angle your arm is at, that tool stays a 90-degree angle from the angle of your arm. You never want to point the tool into space as you're measuring. There's a real tendency to do that when you're measuring something that's moving away from you in space. You tend to want to point the tool into the picture plane, but it's really important that you always maintain sort of a 90-degree angle, whether your tool is being held horizontally or whether you rotate it like it is in the photograph here to a vertical plane. So what we're doing is we're imagining that there's a transparent picture plane, and that's an imaginary surface against which we can measure. And it's almost like you're taking a photograph of an object and then just measuring off on that flat two-dimensional surface the width versus the height of an object. So in this photograph of my husband measuring, you can see that he's holding a pencil in his hand as a measuring device, and he's trying to keep the angle of the pencil at a 90-degree angle from the long axis of his arm. So if you can remember those three critical things, close one eye, hold lock your elbow so that you're always measuring at the same distance from the object, and then also keeping the measuring tool at a perpendicular angle, so a 90-degree angle from the angle of your arm. So regardless of whether you're looking straight out at something or looking down at something or looking up, that angle of your arm versus the angle of the tool needs to stay perpendicular. All right, so let's say that we're going to be measuring a glass. I included a photograph here so you can imagine what the object is that's out in front of me that I'm looking at. And the first thing I tend to do is try to find something that's kind of a medium-sized distance to use as our unit of measurement. So I'll refer back to that. And what you do is you choose one point and you always go back and you measure everything else against that one distance. So in this case, maybe you choose the mouth of the wine glass. So you'd measure straight across from the widest part of that top ellipse, and you would always compare all your other measurements to that one distance. The other thing you could choose is maybe the foot of the wine glass. So you want to find something that you can always go back to that same point, remeasure it to compare other distances. So in this case, let's choose, let's measure the height of it first. So we're going to measure sort of the distance from the front edge of the wine glass to the point where the stem touches the bowl of the wine glass. So the first thing I'd like you to do, and maybe practice this in front of you, find some simple object. I've got a coffee cup or whatever you want to use, something that's not too complex as a starting project, and lock your elbow, go ahead, close one eye, and you're going to be holding your skewer out in front of you. You're going to be lining up the tip of the skewer to, in this case, we're going to have the skewer angled vertically. You're going to line up the tip of the skewer to, let's line up the front edge of the ellipse, just because that's what my photo is showing you to do on the next one here. And then the second step is, once you've got the tip of the skewer aligned with the front edge of the ellipse, then you're going to slide your thumb down. So you're going to move it down and just mark where the thing that you're trying to measure is. You don't have to draw on the skewer. You don't have to use a ruler that even has measuring points on it, but your thumb is going to serve as the bottom of that measurement. So I'll show you kind of what the artist is seeing. So you're holding up the skewer. Again, the top of the skewer aligns with whatever point you're measuring, and then you slide your thumb down until it meets right at the point of the thing that you're trying to measure. So this measurement in itself doesn't mean a whole lot until you get it on your paper. So we're not going to be doing a literal measurement. Oftentimes when you measure off of a skewer, the measurements are pretty tiny because the things are far away. And if you always do a literal measurement where you're just transferring that to your paper, you're going to have really tiny drawings that never fill the page well. So I'm going to have you enlarge things, or control the composition, so you don't need to worry about the literal measurement, whether it was inches or centimeters, but what we're looking at is just a relationship between width and height for now. So we're going to be blocking in the basic structure of the object, and then later we're going to worry about the ellipses, and we're going to worry about the curves of the wine glass, but right now we're just trying to block in the overall proportions of the object. So in this case, we've marked the height of the wine glass. The next step is to count off how many of those heights will fit into the total length of the wine glass. So we're measuring the bowl and comparing it to the length of the stem. So then you're just shifting without moving your thumb at all. You're just shifting the whole skewer down, and we're noticing that the height of the wine glass bowl is about the same as the length of the stem, to the point where about the middle of the foot of the ellipse of the base of the wine glass. So it's a slightly more than 2 heights. And so what you could do is, on your drawing paper, you might just start with, decide how big you want that wine glass to be, and you can just arbitrarily choose a stopping point. But then we know that about halfway down there is where we want So I'm going to draw fairly darkly so you can see it in the video. You can draw a little bit lighter on your paper until you get your proportions worked out. So that's a really quick, rough idea of how big we want our drawing to be. The next thing we want to do is start to establish the width of this wine glass. So what we want to do is go back again and measure our base unit, which is the height of the bowl, and compare it to the width of the bowl. So we've done the height already. Get your thumb marked again where it needs to be. And then we need to rotate our hand. So we're going to just be turning the skewer from a vertical orientation to a horizontal orientation. Again, try to make sure that it's still a 90-degree angle. You're not letting it poke into space, or then your measuring tool gets foreshortened and the measurements are no longer accurate. So you're just rotating to a 90-degree angle, and you're just noticing which is the larger dimension. Is the width of the wine glass wider, or is the height of the wine glass larger? And these are almost the same. So what I can do, now that I've decided how tall the wine glass needs to be, I can just mark with my thumb how big that is, and then we're just going to mark those measurements for the width. So we're going to kind of build this as if we're starting with a big block of stone, and we're going to be carving this wine glass out of this basic rectangle. The other thing you can do is notice a comparison. So you're going to be taking lots and lots of measurements. The more complex the object is, the more measurements you're going to need to take to draw it accurately. So in this photograph, I'm showing that I was noticing how the mouth of the glass is slightly narrower than the belly of the top of the wine glass. So when I'm sketching this, I might intentionally make this, the width of the ellipse up here slightly narrower than the belly of it. So as I do that curve, I'm going to need to make sure the top's slightly narrower here than it is at the fattest part of the bowl. I'm also noticing I'm comparing the width across the top of the wine glass to how wide it is at the base, and I notice that the base is actually quite a bit narrower than the top, even though I might not think that when I first saw the wine glass if I hadn't actually taken a measurement. So one thing that's really helpful at this point for man-made things that are symmetrical is to put a center line in there. That will help us make sure that the right side of the glass is real similar to the left side of the glass. So we know that the base of the wine glass needs to be, it looks like maybe it's just 3/4 as wide as the full width of this wine glass is. So we could estimate what is a 3/4 of that going to look like. So what I did was I just sort of divided this full width into 4 parts, 4 quarters, and I need to take 3 of those to be equal to the base here. And now my goal is just to take this distance and center it on my center line. So I want to try to have the same amount of space on both ends, and that will help me judge, approximately how wide the base of the ellipse of the wine glass needs to be. The next thing to notice, which starts to get more complex, is the ratio of the ellipses. And we're going to talk a whole lot about how to measure those ellipses and draw cylindrical objects. But the basics is we're going to look at that oval and we're going to compare the height of the oval to its width and try to find a ratio between the height and the width, which is going to be greater. So again, lock your elbow, hold up your skewer at a 90-degree angle, and you're going to mark the back edge of the ellipse. It might be that it's blocked a little bit by the stem of the wine glass, but in this case we can estimate where that's going to be because we can kind of follow the curve. And so we mark the top of the skewer to the top of that ellipse, and then slide your thumb down to the point where the bottom of the front edge of that foot of the wine glass is. Then keep that measurement, keep your elbow locked, turn the measuring stick 90 degrees, and you're going to count off how many of those heights will fit into the width. So you're just kind of doing an imaginary, little tack mark. Move your hand over, tack mark again. And for the base here, it looks like it's about twice as wide as it is tall. So I already know what I've established for the width. We're kind of stuck with that in order to keep it in proportion to the rest of the drawing. So we don't want to change that, but we want to take half of that. And it's pretty easy because we have the midline here now. So I just take 1/2 of that total distance, and that is going to be my height. So we're going to fit that ellipse into that area. And since our height, the ellipse actually extended down a little bit below that, I probably am going to kind of estimate. I'm going to draw in that space as a rectangle for now, and then we'll turn it into an oval in a minute here. But this is just basically how to plot out some of the major divisions before we're ready to actually draw the ellipses. Now, you might notice how the ellipses will change, and we'll talk a little bit more about this in the next video, but I do want you to always be aware that ellipses that are closer to our eye level, and that's usually on the end of the object that we can see more clearly, those ellipses need to be flatter. So if the base ellipse is twice as wide as it is tall, this one needs to be maybe 3 times as wide or 4 times as wide. So we'll need to measure that as well. You can't assume that all the ellipses are going to be the same ratios or the same proportions. So you'll check every ellipse in your drawing as we go. So in this case, again, you mark off the height of the ellipse. You're going to be moving your thumb now to a new measurement and lock your elbow. So we're marking off a pretty small distance here. These flatter ellipses are harder to measure accurately because often there's so many of the heights that will fit across the width that it's easy to make a mistake. So you may need to measure a couple of times to make sure that your ellipses are accurate. And then you'll do the same thing. You'll turn your skewer 90 degrees and start counting off how many of those heights will fit across the width. So here's kind of a representation of what that might look like. And usually what I do is I kind of like close my eye and I kind of do a little imaginary tack mark, and then I move my thumb to the point where that tack mark is, move it again, and just kind of count across. And I've had some ellipses, if you've got a mug or something like this and the ellipse is very, very flat, there might be, for the height of the ellipse, it's really, you barely see anything, and when you turn and count across this way, it might be 8 times as wide as it is tall, or it might be 12 times as wide. So the closer it gets to your eye level, the more little measurements you're going to have to fit across the width of the object. So that's sort of the basics of taking the comparison measurements there on the ellipses. And then one last point on how you might use a skewer for this lesson is using it as a plumb line. So if you try to get it oriented as truly vertical as you can. And then you're going to notice which part of the object sticks out further to the right or left than other parts of the object, so that then when you check your drawing, you can notice those same relationships and make sure that the curves are real accurate and that the proportions are accurate.